Hello everyone, Christopher here with McWane Science Center, and I've got a point to prove. By the end of this video, I'm going to prove that point by lighting my hand on fire. This is SciSparks. Stay tuned. Now, before I'm letting my hand anywhere near that flame, let's first see what it can do to this. Now, go ahead and make a prediction. When I bring this balloon into contact with that flame, what will happen next? Are you ready? Let's find out. Well, that was predictable. The heat of the flame warmed the rubber of the balloon and weakened it until the air inside could break free. In other words, it popped. But predictable or not, any good experiment is worth doing twice, which is why I brought a second balloon. But I didn't fill this one with air. We're going to do this experiment again, but this time we'll use our water balloon. Think you know what's going to happen next? Well, let's find out. Well, I'm still dry, which is surprising because, see that? That is soot. That's how we know that the balloon really was touching the flame. And yet, it didn't pop. So, what's going on? The answer, as it turns out, has everything to do with water. Water is an excellent thermal conductor. Basically, that means it can soak up heat like a sponge. When we place our water balloon in the flame, it's the water that absorbs most of the heat, leaving the rubber slightly warmed but cool enough to remain intact. However, when we move the flame to the top of the balloon where there is no water, well, you get the point. But will the conductive power of water be enough to literally save my skin? To test it out, I'm going to need something flammable. In here is hydrogen. And hydrogen is very flammable. Now, if I want to do that in my hand, I'm going to need to get my hand very wet first. And with any luck, it'll be the water and not my skin that absorbs that heat. But there's only one way to find out. Here we go. In 3, 2, 1. Now, for as dramatic as that looked, my skin barely even got warm. And that makes sense when you remember that heat rises. So whatever heat wasn't absorbed by the water was carried up and away from my skin long before it had any time to do me harm. Well, that's it for today. If you enjoyed this video and would like to see more like it, don't forget to like and subscribe. If you'd like to learn more about thermal conductivity, we covered this in more detail in a previous video. Find the link to that one in the description. Or, if you have an idea for a video you'd like to see us cover, let us know down in the comments. Until next time, bye!